Welcome back. Now we will try to analyze a tank system. In this lecture we will try to find out the transfer function of a tank. In the last lecture you have seen that how to calculate the values of the resistance in case of turbulent flow as well as laminar flow. So, in this particular lecture we will consider a tank. In this tank, this is input flow rate and this is output flow rate and this is the resistance, this is the liquid level, and let us say this is the height of the liquid. Now we will try to write a equation which is called mass balance equation, and I will eventually explain each and every term. Now what is mass balance equation? Normally speaking, the mass balance equation is given by rate of mass accumulation equal to rate of mass input minus rate of mass output. This equation is called mass balance equation. Okay, don't worry, I will explain each and every term. So what is the equation? Rate of mass input minus rate of mass output equal to rate of accumulation of the mass, or rate of mass accumulation is given by rho A dH dt equal to rho Qi minus rho into Q naught. This rho A dH dt is called rate of mass accumulation, rho into Qi is called mass input, and rho into Q naught is called mass output rate. Rho into Qi is rate of mass input and rho into Q naught is rate of mass output. Now the question is, what exactly it signifies? For understanding this, we need to take some assumptions. Say, first assumption I have considered this Q naught is greater than Qi. Now you tell what will happen if Q naught is greater than Qi, then the rate at which the liquid is going out from the tank and the rate is in which it is entering into the rate, here the Q naught is greater, means the rate at which it is going out is greater than the rate at which it is entering. It means the height will decrease and at a time it will be empty. So I cannot fill this tank if this is the condition. So first of all, I need to neglect this condition and I need to consider that Qi is greater than Q naught. That means the rate at which it is entering is much higher than the rate it is going out. For that reason, this Q naught is subtracted from Qi. As Qi is greater, so Q naught is subtracted from Qi. Is this concept clear? Why it is mass input minus mass output? Now next question, what is in your mind is that why it is called mass? whether actually this is mass, that is your query. This rho into q naught, whether it is mass or not. Let consider this first term, that is the mass accumulation. Let me write the units of this rho a dH dt. What is rho? Mass by volume. So I can write kg divided by volume, meter cube, multiplied by area, it is meter square. Then dH dt is height, height means meter, divided by time, this is second. So this is the case, kg meter cube, kg divided by meter cube multiplied by meter square into meter by second. What will come? Kg divided by second. Okay, because this meter cube, meter square and meter, that will cancel, kg divided by second. Now I need to find out the units for this q into rho. Rho equal to again kg divided by meter cube, and qi is the flow rate. Again you remember, flow rates are of two types, one is mass flow rate, another is volumetric flow rate. Please remember, in these calculations we are considering the volumetric flow rate. If your sensor is measuring the mass flow rate, then you need to convert it to volumetric flow rate and put here in the mass balance equation. So this qi is a volumetric flow rate. So this much volume per second, this is the volumetric flow rate. Again if you cancel these two, then it will come kg divided by time. Time means it may be considered as second. So if this is the right hand side and if this is the left hand side, you can consider kg divided by 7 by kg divided by second equal to kg divided by second. So you may cut this second and you may consider in left hand side also it is mass and right hand side also it is mass. Need not to cancel this second, because it is given that rate of mass accumulation, rate of mass accumulation, this is the mass accumulation divided by the rate, and here also it is also the mass, rate of mass input. So it is also mass का जो rate है, so it is a rate of mass. Okay, so in each case it is kg divided by second, so the dimension matched. Now we will try to analyze this equation. Okay, what is the equation? Rho a dH dt equal to rho qi minus rho q naught. So after this, after writing this, we will write, after this we will write qi equal to a dH dt plus q naught. If you cancel this rho from left hand side and right hand side, because the rho is constant, we are assuming that rho equal to constant. Why we are assuming this? Because in linear case we will consider the rho is constant in this tank. Now why I am telling this, you might be thinking that why I am stretching this point, that rho will be obviously constant, you might be thinking, then why I am telling that? Seriously, just I will tell you later when I will consider a non-linear case. So, as of now you just consider rho is constant and we have cancelled it. So, qi is equal to a dh dt plus q naught. From here you can write q naught equal a dh dt plus h divided by r from the previous discussion. Okay, q naught equal to h by r for laminar case. Okay, so you can consider it as equation number 1 and this is as equation number 2. Remember this equation number 2 is written, this h by r we have written, it is for laminar flow. Okay. Now, under the steady state condition we can write, so equation up to equation number 2 you have written. Now, under the steady state condition we can write qis equal to qos equal to hs divided by r. This is equation number 3. Now, this might be in your mind, what is this steady state condition? Remember that previously we have written capital Q, that is constant. If it is constant, the height will be constant. Say if this is the tank and QIS is entering and QOS is going out, on that case QOS is going out, and if these two are equal, then the HS will be maintained, is not it? So, that equation we are writing. This is called the at steady state condition. Steady state, SS means steady state. This is not a notation, I am just writing in this way because I do not want to write it completely. You do not write SS, okay? You write steady state condition. Okay, so QIS equal to QOS equal to HS by R. This is the steady state condition. Now, if we combine equation number 1, 2 and 3, I will get QI equal to, sorry, not equal to, QI minus QIS equal to Q naught minus Q naught S plus A D H minus HS divided by dt. It is not divided by dt, it is DHS, DH minus HS dt. In this way you need to tell. Now, what I exactly done? This is the rate of accumulation and this is called input, rate of mass input, and this is called rate of mass output, and this is the rate of mass accumulation. So, this QI and QO are the actual input and output, and this QIS, QOS stands for the steady state condition. So, this QI minus QIS will exactly give you the rate of mass input. Okay. Or you can say we have considered the perturbed variables. Okay. Just as of now you just forget this, try to understand how we are writing. So, this Q minus QIS, let consider it as QI, and Q naught minus QOS, let consider it as QO, and H minus HS, this term we will consider it as capital H. Okay. So, these QI, QO and this H are called perturbation variables. Perturbation, PERTURBATION, perturbation variables. What is perturbation variable? Perturbation variable means if you give disturb or if you disturb the system, then what will happen? This is called perturbation variable. Do not think much on this right now. We will discuss with some example. Just consider that it will be written like this. After that, I will just write this expression like Qi equal to Q naught plus A d h dt. So, you have understood, see, this capital Qi equal to small qi minus qis. So, qis stands for q input at steady state. This s stands for steady state, I stands for input, and qi, this is for qi input flow rate, and this is called input flow rate at steady state condition. Okay. Now, in this expression you can write Q naught equal to capital H divided by capital R plus A dHdt equal to A dHdt in this way. So, it is equation number 4, and I have told you this Qi, Q naught and capital H, those things are perturbation variables. Next, after getting the equation number 4, what we can do? We can take the Laplace transform in both sides. We will get Qis equal to H of s divided by R plus As H of s, or you can write Gp of s equal to H of s divided by Qi of s equal to R divided by RAS plus 1 equal to, you can write K divided by tau s plus 1. So, why we have written this Gp of s equal to H of s divided by Qi of s? Again, remember the tank, this is your Qi, this is your, this is again need to be understood Q naught, and this is called R, and this is the height. Most of you people will think that the input to the system is Qi and output to the system is Q naught. Sorry, one second, Q naught is not coming, one second, Q naught. Okay. So, most of you will consider that this Q naught is the output and Qi is the input. So, here the Gp of s, you understood, Gp of s is the transfer function. What is transfer function? By definition, Laplace transform of output by Laplace transform of input. Now, you will say that the Laplace transform of output must be this Q naught of s divided by Laplace transform of input, that is Qi of s, that must be the transfer function. Most of you will tell this is the transfer function, sir, because it is the output and this is the input. But you remember what is our purpose of this system? What is the purpose of the system? To apply some input, there will be some obvious output, but we will get, due to this, we will get a change in the height. So, our target is to increase the height or level, that is why this H is the output of the system. That is why we have considered Laplace transform of output divided by Laplace transform of input. Remember this, in this system, this H is the final H is the output and this Q is the input. That is why we have taken Hs divided by Qis. Rest of the things are you just take the common and in both sides H of s will be 1 divided by R plus As. From that if you can calculate it, it will come. Okay. Now if I consider this k divided by tau s plus 1, so it become the transfer function. Now this k equal to R and tau whatever we have considered as Ra from this equation. So this Ra is given by tau and this R equal to given by k. So what is this tau? Tau equal to time constant and k is the gain of the system. So in this way you can find out the transfer function. Now if in some cases, those cases will come when we connect one tank with another tank, on that time we need to find out the transfer functions. There we will consider another transfer function whatever I have just now told, that q naught, if I want to find out the q naught divided by qi. If I want to find out that transfer function, then we will write that q naught, qi value I know, then q naught of s equal to h of s divided by r. This will be the q naught of s. So if I find out Gp of s, I will get q naught of s into r divided by qi of s. So what is q naught of s? Q naught of s equal to this q naught of s into r, this h of s value I am putting. What is the transfer function? Transfer function is h of s divided by qi of s. Okay. So this h of s divided by qi of s. So this value of h of s equal to q naught of s into r divided by qi of s. Okay. So from that you can find out the value of q naught of s divided by qi of s. If you put the values, you will get RAS plus 1 and here you will get q naught of s divided by qi of s equal to 1 divided by tau s plus 1. So this is the expression for Gp if you consider this q naught is output, qi is input. Here nothing is the effect h of s. So from this equation h of s, what is the value of h of s? Equal to q naught of s into r. That value we have put. Gp of s we all know that it is h of s divided by qi of s. So the value of h of s we have just put. Okay. So whatever derivation we have done till now, it is all about for laminar flow. Now we will consider a turbulent flow. For turbulent flow, let us consider this q naught equal to k h to the power half. Using the now you can expand this nonlinear exit flow. You can easily understand na, this is a nonlinear exit flow. So q naught equal to k h to the power half. Square h to the power half means square root of h to the power half means square root of h. Square root of h means it is a nonlinear expression. So the nonlinear expression may be expanded using the Taylor series expansion. So using Taylor series expansion we will get q naught equal to f of h equal to k h to the power half, is not minus k, k h to the power half. So, you will get q naught equal to q naught s means steady state plus h minus h s dou q naught dou h at steady state plus higher order terms. So, from here you can write capital Q naught equal to capital Q naught means what? Q naught minus Q O S. If you take Q naught in this side, so it will become Q naught S equal to H minus H of S equal to capital H K half H S to the power half. If you take the partial derivative, you will get in this way. So, after that you can just consider or reconsider this by divided by h divided by 2 h of s half here one minus half will be there, minus half. So, it will be half divided by k. So, in any means you need not to write this, you may keep it up to here. This is will be the things, and this is for the, and ultimately you will get h divided by r. This will be h divided by r. So, what is this r? This r is this one, this term. This whole term you have to take here, and that will be considered as capital R, and this R is for turbulent flow. So, in this way you can find out the output flow rate of turbulent flow rate. Okay. And then similarly you can put it in q0 by qi, and you can find out the transfer function for turbulent flow. Remember this, in industry most of the flow rates are of turbulent in nature. Most of the flow rate are in turbulent in nature, but the calculations are very easy in laminar flow, and whatever turbulent flow calculations we have seen, remember that it is a linearized equation, because using the Taylor series expansion we have linearized it. Whenever you linearize a function, it means that you have not considered all of the situations or all the non-linearities you have not considered. For simplicity of ease of calculation only you are considering the things. Okay. So, this ends the